Hi my dear student, today we will discuss chapter 2 complex number. We will discuss the property. Prove that argument of Z1 by Z2 equal to argument of Z1 minus argument of Z2. So let us take the complex number Z1 as in polar form, r into cos theta plus I sin theta. Here r1 into cos theta 1 plus I sin theta 1. In exponential form, r1 e power I theta 1. Z2 r2 into cos theta 2 plus I sin theta 2. In exponential form, r2 into e power I theta 2. First find out the argument of Z1. So argument will be for this complex number Z1. So it gives tan inverse imaginary part r1 sin theta 1 by real part r1 cos theta 1. So r1 cancel, sin by cos tan theta 1 with tan inverse. So tan inverse of tan theta 1 gives theta 1. Similarly, I can write argument of Z2 will be theta 2. So therefore, argument of Z1 minus argument of Z2 gives theta 1 minus theta 2. I will take 1. Argument of Z1 is theta 1 minus argument of Z2 will be theta 2. For the left hand side, find out argument of Z1 by Z2. First find out Z1 by Z2. What is this? R1 e power I theta 1. R2 e power I theta 2. R1 e power I theta 1 divided by R2 e power I theta 2. It will be R1 by R2 e power I theta 1 minus theta 2. R1 by R2. When this e power I theta 2 comes to the numerator, e power minus I theta 2. So I can take I as common, theta 1 minus theta 2. So it will be R1 R2 cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. Taking argument of Z1 by Z2 will be tan inverse imaginary part R1 by R2 sin theta 1 minus theta 2 by real part R1 by R2 cos theta 1 minus theta 2. So it will be these two get cancelled. Tan inverse sin by cos tan theta 1 minus theta 2. It will be theta 1 minus theta 2. I will take 2. So what we have from 1 and 2, theta 1 minus theta 2, theta 1 minus theta 2. So from 1 and 2, argument of Z1 by Z2 equal to argument of Z1 minus argument of Z2. Got it? Very simple. Let us define Z1, Z2 in polar form. Taking argument, tan inverse imaginary part by real part. R1 cancel, tan theta 1. Tan inverse tan cancel, theta 1. Similarly, finding argument of Z2 will be theta 2. When you subtract this one, you will get. For the left hand side, find Z1 by Z2. So R1 by R2, this e power I theta 2 comes to the numerator, e power minus I theta 2. So when you multiply, you can add the power. So it will be e power I theta 1 minus theta 2. Write in this format, taking argument, tan inverse imaginary part by real part. These two get cancelled, sin by cos tan. Again tan inverse tan cancel. It will be theta 1 minus theta 2. So argument of Z1 by Z2 equal to argument of Z1 minus argument of Z2. Got it?